Today we are going to see the last method for solving quadratic equations. So this method is called the quadratic formula. That means we will use an established formula to solve the equation and obtain the answers. So knowing that a second degree equation has the structure ax squared plus bx plus c equals 0, remember a is the coefficient of the x squared, b is the coefficient of the x, and c is the independent term. So in this case, we can use this general formula that I have here to solve any of the quadratic equation. Of course, we can have that b or c equals 0, and we can put a 0 in the specific place of b or c. So the important part is, of course, the general formula is going to be x equals minus b plus minus the square root of b squared minus 4ac, all of it divided by 2a. But first of all, to use it, we must have an idea of how they obtain this general formula. So let's see how to obtain the general formula. So if we are telling that the structure of a quadratic formula, it's normally ax squared plus bx plus c equals 0, we will use with this structure the last method that we saw, the completing the perfect square trinomial, in order to isolate the x and obtain the general formula. So let's see. First of all, to complete a perfect square trinomial, remember we need to divide in this case by a, because we need that the x squared must be alone. So it's going to be x squared plus b divided by a multiplied by x plus c divided by a equals 0. In this case, we can change the independent term, that is going to be the c term, to the other side. It's going to be minus c over a. Then we need to complete the perfect square trinomial. Remember, to complete the perfect square trinomial, we must have something squared that completes me that trinomial, that it's going to be the middle term, that in this case it's going to be b over a, all of it divided by 2, so it's going to be b over 2a, all of it squared. I need to put exactly the same on the other side, not to modify the original equation. So it's going to be, this one is going to be x plus b over 2a, all of it squared, equals minus c over a plus b squared over 4a squared. So what happens here? I need to have them on a single fraction. So the least common multiple, it's going to be 4a squared. That means if we compare the first one, we need to multiply by 4a. So it's going to be minus 4ac. The second one has already the same structure, so we copied the b squared. And on the other side, we have x plus b, all of it divided by 2a, all of it squared. So let's continue doing it, and it's going to be, we can change the square power as a square root. So it's going to be the square root, and if we put it in order, it's going to be first the positive b squared minus 4ac, all of it divided by 4a squared. So what happens next? It's going to be x plus b, all of it divided by 2a equals, we can take out the square root of 4, it's 2, the square root of a squared, it's a, and on the top part, I will still have the square root of b squared minus 4ac. So the only thing that we are missing here is going to be, we can change this one to the other side, minus b over 2a. It's going to be plus the square root of b squared minus 4ac, all of it divided by 2a. So we can put them on a single fraction, 2a minus b. And normally, just to remember that Square root has a positive and a negative answer. They put here plus minus the square root of b squared minus 4ac, all of it divided by 2a. So if we check this one and the quadratic formula, it's exactly the same. So of course, this procedure, we don't need to make it because it's already known that the quadratic formula is x equals minus b plus minus the square root of b squared minus 4ac, all of it divided by 2a. But it's important for you to know how they obtained this specific formula. So now let's see some exercises on how to apply the general formula to solve an equation. So in this case, we have this equation and we need to solve it by the quadratic formula. So the first step is going to be eliminating all the parentheses and transform the equation to have the structure ax squared plus bx plus c equals 0. So let's see. A binomial squared is going to be the first one squared minus 2 times the first one multiplied by the second one plus the second one squared. Then it's going to be the first one squared minus 2 times the first one multiplied by the second one plus the second one squared. Then it's going to be minus 5x minus multiplied by minus, it's plus 10 equals 11 minus 8x. So if we change everything to the left side, it's going to be 9x squared plus 9x squared. Then it's going to be minus 6x minus 6x minus 5x plus 8x. Of course, plus 1 plus 1 plus 10 minus 11 equals 0. So it's going to be 18x squared. Then it's going to be minus 6 minus 6, it's minus 12 minus 17 plus 8 is going to be plus 9. Minus 9 minus 9x. 1, it's 2, 12 minus 11. It's going to be plus 1 equals 0. So now we have that a equals 18, b equals minus 9, and c equals 1. So we can apply the quadratic formula. X equals minus b plus minus the square root of b squared minus 4ac, all of it divided by 2a. X equals then minus multiplied by minus, it's plus, so it's going to be 9 plus minus the square root of b squared, that it's going to be 81, 9 squared, minus 4 that multiplies 18, that multiplies 1, all of it divided by 2 times 18. So if we continue doing it, it's going to be x equals 9 plus minus the square root of 81 minus 4, 72, 72, all of it divided by 36. So in this case, it's going to be 81 minus 72, x equals 9 plus minus the square root of 9, all of it divided by 36. So it's going to be x equals 9 plus minus 3, all of it divided by 36. That means we have x equals 9 plus 3, all of it divided by 36. So it's going to be 12 divided by 36. Both are divisible by 3. and by 4 also. So if we divided this one by 4, it's going to be 3 and 9. And if we divide it by 3 also, it's going to be 1/3. That means x equals 1/3. And let's see the other one. It's going to be x equals 9 minus 3, all of it divided by 36. That means x equals plus 6 divided by 36. Both are divisible by 6. That means x equals 1/6. So these are our two answers from x. Of course, if we want to do the verification process, we need to verify both answers on the original equations. We are not doing it because of time issues, but if they ask you to do the verification process, it's like always. We use these values of x on the original equation, and we will be able to solve or to see if the solutions are the solutions for the equations. So let's see another example. So in this example, it's exactly the same. We have parentheses. So first we need to have the structure of an ax squared plus bx plus c equals 0. And after that, applying the general formula to solve the equation. If we remember about special product, this is a binomial times a trinomial special product, because this one is the first one squared. This one is the multiplication of the two of them positive. 7 times 3 is 21x. And this one is the square root of this one. So that means the answer is going to be a difference of cubes. That it's going to be the first one cubed minus the second one cubed. Then we will continue. It's going to be minus 2x plus 2x squared equals 27x cubed minus 243. So this one is going to be 27x cubed minus 243 minus 2x plus 2x squared, and we can change them to the other side, minus 27x cubed plus 243 equals to 0. That means this one with this one can simplify, this one with this one, so we will have only 2x squared minus 2x equals 0. That means a has a value of 2, b has a value of minus 2, and c has a value of 0. So what happens in this case? We can use the general formula to solve the equation. So let's see, x equals minus b, minus multiplied by minus, it's plus, so it's going to be 2, plus minus the square root of b squared minus 2 squared is going to be plus 4. Then it's going to be minus 4 that multiplies a, that multiplies c. All of it divided by 2a. So what happens here? Everything multiplied by 0, it's 0, so it's going to be only the square root of 4. All of it divided by 4. So what happens next? It's going to be x equals 2 plus minus 2, all of it divided by 4. So we have x equals 2 plus 2, all of it divided by 4. That means going to be 4 divided by 4. That means x equals exactly to 1. And the other one is going to be x equals 2 minus 2, all of it divided by 4. It's going to be 0/4. That means x equals 0. So we have the two answers for x. X equals 1, x equals 0. That means, of course, if we remember a little bit about last topics, that it has two solutions. It will cross the x-axis on 1 and 0. And of course, maybe we want to know, it will cross the y-axis also on 0, because the value of c equals 0. So that was using the general formula to solve this quadratic equation. As we saw, the general formula will apply for every quadratic equation. That's why it's so important, because if we remember, on the perfect square trinomial, we must have a specific structure. On the factoring cases, we need to have a factoring case specifically, but the quadratic formula applies for every exercise with a quadratic equation. So let's see another example. So what happens in this case? Exactly the same. First, we need to get rid of the parentheses and so, and after that we have the structure of ax squared plus bx plus c equals 0, and after that apply the general formula. So this one is the product of the sum and difference of a binomial. So it's going to be the first one squared minus the second one squared. So let's see. It's going to be x squared minus 8x squared plus 2x minus 4 equals 0. Minus 7x squared plus 2x minus 4 equals 0. That means a equals to minus 7, b equals to 2, and c equals to minus 4. So let's apply the general formula for solving the equation. It's going to be x equals minus b plus minus the square root of b squared minus 4ac all of it divided by 2 times a. So in this case, it's going to be x equals minus 2 plus minus the square root of 4, and it's going to be minus multiplied by minus multiplied by minus. It's minus. In this case, it's going to be 16 times 7 minus 112, all of it divided by minus 14. So what happens next? It's going to be x equals minus 2 plus minus the square root of minus 108, all of it divided by minus 14. Of course, we can think that this specific equation has no solution because we have the square root of a negative number, but maybe we can find a solution in terms of I because we know how to obtain the roots of a negative number. So maybe we can obtain the answer in terms of I. First of all, we have the square root of minus 108. So we know that it's going to be the square root of 108 multiplying the square root of minus 1, and this one is going to be I. If we decompose the 108, it's going to be 108 divided by 2, it's 54, divided by 2, it's 27, divided by 3, 9, divided by 3, 3, divided by 3, 1. So it's going to be 2 squared that multiplies 3 cubed. So we can take out a 2, we can take out a 3. On the inside part, we'll still have a 3 and an I. So it's going to be 6, the square root of 3i. That means this one, we can put it like x equals minus 2 plus minus 6, the square root of 3 multiplying I, all of it divided by minus 14. So that means going to be first x equals minus 2 plus 6, the square root of 3i, all of it divided by minus 4. So we can simplify because everything is divisible by 2 or minus 2, and we can put it as, we divide everything by minus 2, it's 2 here, 1 here, minus 3, the square root of 3i. This is going to be one of my answers. The other one is going to be x equals minus 2 minus 6, the square root of 3i, all of it divided by, I'm sorry, here was minus 14, so it's going to be 7, not 2. I forgot. Here it's going to be 7. And on the other side, minus 14. So it's going to be everything it's divisible by 2. So, or minus 2. So it's going to be 7, 1 plus 3, the square root of 3, multiplying I. Those are my answers in terms of I. So we have the opportunity that using the quadratic formula, we can have real solutions, only one solution, or even we can know the solution when we have imaginary numbers. So that's why the quadratic formula is so important, because we can use it for only one solution, for two solutions of either. If we said that it has no solutions, maybe we can obtain a solution in terms of I. Of course, if we can think about the graphic of this specific formula, it won't touch the x-axis because the answers of x are imaginary. So in this case, why? Because the determinant, that it's the part, the discriminant, I'm sorry, not the determinant, the discriminant, that it's the inside part of the root, it's smaller than 0. So that's the importance of the quadratic formula. So we can use the quadratic formula on any of our equations. It doesn't matter what type of solution we can have. With the quadratic general formula, we can obtain the answer. So that was it for quadratic equations using the quadratic formula for solving the second order or second degree equations.